Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahir Farhan and my supervisor is Dr. Aida Bintan. Today I'm going to present on project sarjana number 2 under the title UTM Event on Google Map Augmented Reality. So this is the outline of the presentation. We have 6 main topics, which is introduction, literature review, system development methodology, implementation, testing and evaluation, and conclusion. So the introduction. Problem background. COVID-19 pandemic has caused the physical event cannot be conducted because of standard operation procedure. This situation forces organizer to think of new idea on ways to commence event without diminishing the event merriness. And also we want to store event memories and merriness digitally. So the objective of this project, first one is to analyze the virtual object that will interact with user and real object in the scene by location-based AR using Google Map for UTM event. To design and develop location-based AR using Google Map application that allow the user to experience an event that had taken place in UTM campus. And the third one is to evaluate the location-based AR using Google Map application that allow the user to experience an event that had taken place in UTM campus. So the project scope, this application is designed to be used in the UTM campus as the location marker and purpose are unique in UTM. The project core feature is ability to detect marker according to coordinate given around UTM rather than normal ground and plane around us. An additional feature of this application is ability to discriminate between foreground and obscured building. This feature offers precise and valuable information for the user. So we move along to the literature review. So there are 4 main categories of augmented reality application, which is game, 3D viewers, browser, and GPS. So finally is GPS-based AR. It allows for object to be placed in any location as long as the user has the application and the internet to allow retrieval of data regardless of time and weather conditions. So these are the example of type of marker. We have marker-based, markerless, and GPS AR. So in this project, we use AR Core as the software development kit. AR Core by Google is powerful as it offers light estimation feature and that enhance realism property to 3D object. Besides, it has motion tracking ability that allow motion detection and trigger visual element according to camera tracking. Using AR Core, this project can be developed as it has feature that can enhance the usability of the project. So finally, we have event in UTM campus. So UTM is a government-funded public university with a focus in science, engineering, and technology. Majority of students here are Malaysian, consists of Malay, Chinese, and Indian, and Burmese. Apart from the local, international students from Indonesia, Egypt, and also others choose to study in UTM. The fusion of multicultural students allow UTM to host number of amazing events, for example, Pesta Tanglong, festival, Hari Raya, UTM Global Village, and other interesting events that worth to be experienced by everyone to feel their study life. So in this project methodology, we will discuss on the data source, which we will discuss on the point of interest and their coordinates. So we have 4 main point of interest, which is Parangkau UTM, Tasik UTM, Observatory UTM, and Dewan Sultan Iskandar. So this here shown their respective coordinates. So system development methodology. So in this project, we use the ADDIE model, which is analyze, design, development, implement, and evaluation. During every stage, it is very encouraging to look back at the 4 stage and evaluate what step and requirement needed in order to move forward. So here we have the methodology workflow. We have analysis phase, design phase, development phase, and evaluation phase. During the analysis phase, we will analyze the location-based AR. We want to know the requirement, the non-requirement, and also what needed to develop the application. Design phase, we will design the interface and AR element. Development phase, it is divided into 2, which is location-based AR. We study on tracking method in markerless AR, and we use object placement using AR Unity. And secondly, UTM event, which is we study what needed to replicate an environment. And also we study the point of interest for every GPS data of point of interest in UTM. And then we implement it using the AR Core. And then we develop it. Finally, we have evaluation phase where the project will be tested by user and we will take their feedback to determine the success of application. So analysis, user, application, mechanism, and implementation methodology. And application design is outlined. The AR SDK involved, AR element needed, and application interaction is included. Requirement analysis include functional requirement and non-functional requirement is listed. So we have the design phase, where here the design phase is represented by use case application, where we can see the user and also the use case of and the activity that user can be done using the application, where application verify user location, user view particular location, open application camera, point camera to location or AR marker, and view events in AR, interact with interactable model. And finally, we have the design framework, where in this part, it is quite technical, where we will part the diagram into visual scene integration and also outdoor, which is we can see here from the POI or point of interest, we have visual integration, terminal display, terminal camera, and it is sent into visual scene integration, where this activity exists in the technical part itself. So finally, we have the design methodology. So here we will explain on the system architecture, where we have three main level, which is application level, that what the user see, and also service level, which is the backend, and data level, which is also the SDK part. So during the application level, there are three main things, which is system interaction, video input, and AR object display. Second level, motion tracking and target recognition, and environment understanding. And finally, we have basic information database, recognition data, target database, and AR information database. This process of data level is happening in the SDK itself. So we move on to the next topic, which is implementation. So the implementation start with the AR element development. The augmented reality object in this project is created using Adobe Photoshop and imported into Unity to be used as the 3D object in AR development. Most of 3D assets are from Unity Asset Store. So we can see here the AR element produced. We have a lantern festival scene, which is a 3D object, and we have a floating lantern, which is also a 3D object. So for the UI development, the first process started with the mockup of UI is designed using Adobe SD. It is exported into individual element in Unity, and individual material is converted into 2D and UI sprite so that it can be used in Unity. And finally, it is attached to game object UI in Unity so that we can use it in the application later. So this is the result of the UI development. We have homepage. So at this homepage, there are explore, about, and create button. And also we have places menu, which is from this menu, user can do two things, which is the first one to navigate to POI, point of interest, and the second one is to open the camera. To open the camera, user only need to click on the image places in the places menu. For the navigation, user can click at the direction button. So finally, we have the flowchart of the application. So in this implementation, we follow this flowchart so that we can visualize how the application will work from a button to another. So we have start, and the first application start, we will go to main menu, and also we click the explore, we can go to places menu. So from the places menu, there are two activities, which is open camera by clicking the image, and the second one is redirection using Google Maps. So implementation process. So there are three main things in implementing this process. First one is the setup environment, where this is the back end of our application. We have AR Foundation season manager and AR session manager using the AR SDK. And the second one is the scene manager, where the programmer itself will put the 3D object in the scene and manage it using the script. And finally, we have the AR session, which is how the application and how the scene that is is connecting with our SDK in order to create an AR event. So this is the script where we attach it to location provider game object, where it retrieves GPS object that hold the place at location script component. The component gets the GPS input, which are latitude and longitude property for the setup of the POI AR event coordinates. In addition, the properties of this game object are saved to location data. Finally, the data is hidden and only shown if the application GPS property is matched to the geolocation property of AR event set up using the place at location script. This altitude mode is set to ground relative so that it detects all flat surfaces as an AR surface. So this is the game object that collect the GPS data and send it to another script for so that we can spawn the 3D element on a certain GPS location. So we have a location AR camera property here, and also how the AR camera is placed in the scene so that we can see a view in our AR application later. So the implementation of AR camera, the AR scene need a camera in order to see the visual element or AR element. Figure, the game object, a camera named as AR camera is set as the main camera of the scene. As we can see here, this is the main camera. So the view in our application will be using the AR camera view. So implementation, placement of AR element. The placement of object happens in a runtime. At the start of the AR session, the script placed at location will take the GPS coordinate of application and then compare it to the GPS property of element in the database. If it is true, the object under the GPS stage object is spawned according height and average camera movement. So the script will spawn our AR element as it will compare the GPS stage object location and the GPS we set in our database. So implementation, we have a scene manager. So the scene manager responsible to manage scene. The navigation between a scene to another is controlled by two scripts, which is scene switcher and select scene. Scene switcher is used to navigate between a different scene to another scene, while select scene is used to navigate between game object in same scene. So this process is happening in Unity. So the scene switcher and select scene allow the application to UI to move around and in between scene and also function. So this is the script for scene switcher and select scene. So finally, we have the evaluation for this project. So this is the evaluation setup where we will conduct tests for the application on the UI and also how the application works using GPS. As you can see here, this is how the application works. We have a purple line that shows where our AR element is found, and we also can see the AR element and do the interaction using our hand gesture or using camera movement or button tap. So our project is also tested by 8 male students from UTM. The opinion of user towards AR application can be seen through the survey below. So firstly, we ask the user on their familiarity with AR, and then we ask their opinion on the difference between AR event and real event. We ask either an real event can replicate an AR event. So all of the testers answered yes to the question. However, for the preference, they said that the applications can replicate the event, but the experience is far more different. So finally, we have the user acceptance using black box testing, which will test the application user acceptance, which is UI. So there are 12 criteria, which is opening UTM Event AR application, user click on explore button. So this testing involves testing the UI and function of our product, in which all of this requirement, 12 tasks is done by the tester, and they can carry out the task gracefully. Finally, we have the testing and evaluation usability. Usability testing involves a number of aspects and consists of various factors, such as functionality of application, easiness of user interaction, and design understanding. This aspect aim to test user satisfaction, memorability, desirability, and credibility. So for the result on usability test, we have gathered the feedback from them. The first question would be the interface of this application is pleasant. 3 of the testers give a mark of 5 out of 5, and 5 of them mark at 4, which is good for them. And second question, it was easy to navigate in this application. 6 of the testers answered 5, while other 2 answered at 4, which give the meaning that our application is easy for them to navigate. And then it was easy to understand the application objective and function. So 7 of the testers answered at 5 and 1 answered at 4. And the last one, the UTM event at the place of interest resemble the actual event that has taken place. 5 of the testers answered yes to this question, and 3 answered at 4, in which it means that the application deliver the UTM event AR at positive resemblance. So finally, the conclusion, we have created a location-based AR application We also create UI and place at location script to allow the spawning of AR element in using GPS AR. We identify AR element to resemble UTM event. We allow user to experience UTM event on significant in UTM campus. And finally, we test the application on UTM student and collect feedback regarding usability and acceptance. So that is the presentation for PSM 2 for topic UTM event using Google Map augmented reality. Thank you everyone for your attention. My name is Muhammad Syahir Farhan. Thank you.